same answer, maybe. Did you do it the same way? Did you do something differently? You guys do it the same way? How'd you do it? Just set up two equivalent fractions?
Which one? Which one
Okay.
has the same?
And if they're equal, then you're good to go.
Jefferson? Oh, you had the phone?
I didn't even look at all of the answers. I just looked at the first one and knocked off the zeros. And I saw 235.
Which one has the same ratio? Jefferson?
Oh, once I simplified my answer
Yeah?
from the first one, I looked at the first one and knocked off the zeros. I saw 2 and 35. So
And you were good to go. So you did the first, you just handled the question ratio first, and then you looked at the answer.
That's what they call other knowledge.
I would force the kids to check all 4 of them though, to make sure that there wasn't a mistake. But then I would also use strategy.
So going around the room, you got some different ways that you can work on this problem.
Oh, you could do it like,
Tim in the back decided to set up 2 equivalent fractions and cross multiply. Francis decided to simplify the ratio in the question, and then recognize once that ratio was simplified, she could just knock off the zeros in A. Were there other stuff? I didn't really get to this side of the room. Was there another method, other methods that you could think through? Yeah?
Oh, I noticed that 350 and 210 are divisible by 7, so I reduced those and that worked out and I was happy.
Right? So 210 and 350, those are the only numbers there at all. Well, the 14, but in terms of the students that are divisible by 7s. So you can recognize those similar prime factors that are in there as well. So again, there's lots of ways that you can attack these. How can you use these different methods to prepare your students?
What would our kids be struggling with, right? What would kids, what was important, like this is a lot of high kind of numeracy knowledge, right? A lot of, oh, did you hear that? Can you say it a little louder?
Change everything to decimals. Just show them that they can use the calculator.
They've got to,
Oh, yeah.
okay, so that's interesting, to check equivalent fractions, right?
You know, it's a choice. They have to have a set of choices presented to them. This way they can make their own selection. The price,
Okay.
like the online test.
Price book online test. Other things to say? Right, reducing, you know, a benefit of reducing fractions. Is that something that they're going to be comfortable with and not make errors? Or is that not a good route for them? It's an interesting question. Is it simply a motivation?
It could also be the student that you're dealing with, because you might have that student who by choice wants to simplify the fractions, and you have another student who by choice wants to work with the decimals. So it's by their choice, which one do they know they're more comfortable with, and which one are they more confident with? Because you might have that third student who wants to reduce the fractions and then check their work by finding the decimal values.
Yep. Do you think they read this problem and understand it? What it's about?
Yes.
Same ratios. What has the same ratio? This one, right? Again, different kids might be at the yes, and some kids might be at.
Some kids would like to simplify the fractions and use the cross product. I see my kids would do that.
And then what do they do from there?
And they see if they're equal.
Is that their method
Similar
of
to,
checking?
similar to your method back here, yeah.
Yeah.
No, I was gonna say, I think my students, if I just gave them this problem without doing any prior work, they definitely would not know. I don't think they remember what ratios are or any. I think we gave this problem after working on it for a few days, then.
Right. Right.
they would, but
And
if I
this-
walked in tomorrow and gave it to them.
This is why we have that proportional reasoning section in the curriculum. I mean, it's here. This is a sample. This is pulled from a compass exam.
See, but I think this question actually aligns itself with lesson 2.1, where
You know
they
these by
actually
number.
have to do the number line activity, and they have to find 7/8 on the number line, but you only divided the number line up
Yep.
into fourths. So you are basically finding an equivalent ratio or an equivalent fraction for them to work with. So if you did a question like this, after you did the number line activity with them, it would align itself to how can you apply this number line activity to an actual question.
Of course, they don't get to face those things being aligned when they're sitting down for
Right.
that test on everything. So, right, so there's decisions, like maybe it becomes, again, it could become a motivator of being in that material to say, look, here's a sample, to be able to pull that out at that moment, right?
So we went through some strategies for solving. I'm actually giving you another problem now, and this is not in with any of the curriculum. This is dealing with integer operations. But again, a problem they may be presented with to simplify the following expression. And so while you're solving this and going through, thinking about where are the difficulties that your students might get hung up with this particular problem? And are there different ways that you can go through and different things that you're thinking about when you're solving this problem? Yes?
I think that if they had good number sense, they know the answer should be close to 150. Because it's 49 times 3, so
Yeah.
that should be the answer in a second.
For that portion, for that multiplication.
no, because
In general.
in general,
Approximation is a
because
skill.
you get 49 times 3, which is almost 50 times 3, which is 150, right? So the answer should,
Do you?
Is it?
No.
Oh.
Also, we'll have problems with the other.
Wait a
He's
minute.
stuck on Amazon Island.
oh,
Yeah.
Okay, I'm sorry. You got good number sense, you get, okay, I got it. You got negative, let's say you got negative 50 times 3, right? Which is going to give you close to negative 150, right? And
You make
negative
it
2
positive.
minus negative 150, which is give you close to 148. So you're going to close anyway.
So what are the difficulties that different students might have, right?
They will subtract first.
Because we're not worried about you. We're actually concerned about
I
you.
mean,
know
most of them,
that.
I mean, most of them will do it so quickly that they will subtract first.
Ah,
Right, so first recognizing that this
Yeah.
isn't a problem that has subtraction in it, really. Liz?
I'm sorry, what'd you say? Is it a problem that has what?
Is it a problem that has subtraction?
Addition, subtraction, whatever we're gonna call it, it's like, because if you're adding two integers from different sides, you're gonna subtract anyway, so in a way it is subtraction.
Why did we, or why did most of us have to say, what do I do first? Why do some people get that and others not, right? Why might our students, for us at some point, the trigger of, oh, what do I do first? Or, oh, this has to be done first. Versus the population for whom that's not what pops into their head, right? And how do we help them with that?
I guess students at this point know what are operations, but even with like PEMDAS and all that, the biggest thing that students, they don't understand that like multiplication, division are have the same weight, adding and subtracting has the same weight. They always think multiplication has to come before division. Adding has to come before subtraction. So that whole thing, so it's like, they never really understood it, they memorized something, and then had to, like PEMDAS tells me to do this, and I don't really care if it makes sense or anything, that's what it tells me to do.
And I agree, when you get to high school, you have to break them up a habit. Friends gave a test, and I said, where was the mistake? They all said they did division before multiplication, not thinking, and that's why the first day I say, it's a great tool, but all of them have to forget what they learned in middle school in terms of that, because unless you figure out that multiplication, division are equal, they're coming into high school, all of them doing it backwards.
And another common mistake for those kind of problems is my students try multiply -2 and -1, -2 distribute to inside.
Yeah, actually, that's.
See parentheses, and so
Yeah,
they
they
distribute.
think
You must distribute, they don't see the negative.
Yes?
A lot of my students see all those negative signs, just have an anxiety attack. They don't equate sign numbers with order of operations. They were different lessons. They were different weeks. One does not apply to the other, which is whatever. What really makes me upset. That's what they do. Of course, you wouldn't multiply because that's not first, because this is a completely different problem than order of
Right,
operations.
it's not on that, we're not on that
Yeah,
chapter.
exactly.
Well, I mean, the whole problem is it's really has no context for kids. What is that? What's the context? They sit there and they go, okay, what's the algorithm? What's the mnemonic that I use?
Right,
So, I mean, so if you really, so you're saying you want them to have the conceptual understanding, but this is -2 minus, they're going, that's just discrete.
right.
For
So
them.
that brings up that argument. Where do we go, especially with integer operations, in terms of conceptual and versus that procedural knowledge? So a lot of our students maybe come in and just have this idea of, okay, with integers, with negative numbers, it's just, there's a rule that I have to follow for multiplication and a different rule for division, and what are those rules, and how do you inject that conceptual understanding in with integers? And so I do have some handouts that kind of discuss some of this. It's two each, but
Okay.
and so one of them is kind of the concept behind multiplying integers, and the other and the other is with addition and subtraction. And so this might give you some ideas as to how to handle those concepts.
There's two, right?
Yes, two.
Okay, cool.
There's two. And so we are encouraging you to spend some time on these integer operations. There are problems like this that they will see on the Compass exam, especially if they get knocked down. So it's not something that is specifically discussed in our curriculum, but you can use this Compass prep time that we've built in to spend some time kind of brushing up on some of these other topics. Because this is something that they will see, and we all know in this room this is something that students do still struggle with at times. So I'm giving you a couple of resources where you can find some Compass and Compass-like problems. So again, some of these links we might have given you before. The top one is just to a PDF, and that's straight from the Compass website. Again, you don't have to write these down. We're going to send you this PowerPoint as well, so you don't have to worry about taking pictures if you want. So there's the Compass site. There are a couple of other sites as well. Hostos Community College has a lot of good preparation material there for you, as well as there's another site called EdReady, and BMCC's site has a lot of stuff. It's not too difficult to kind of Google and find some practice Compass problems. And once you see what the problems are like, you can probably generate some of your own. We've also created, in the likeness of the curriculum that we've handed out,
This is like January and June.
Some additional materials. Yes.
Other than the host those sites, because I've been there before, are any of these sites, would any of these sites provide like a practice exam that the kids can work on? I know at the host those site, they like, you could click on a certain section and you can answer like 10 questions and you can see how you did on those 10 questions. But do any of these other sites have like an exam, even if it's just on a specific topic, where the kids can practice taking an exam online?
Topic specific?
It could be
Or-
topic specific or an exam specific, just so that they can actually practice using the computer on the laptop.
The EdReady site is of that style. It
Okay.
does give you, there's a question that pops up, and before you move on to the next one, you have to select the correct multiple choice one, and it'll go through, and there's a progress bar as well. So
Okay.
it has that type of style. I don't think it's adaptive like the actual Compass is, but
Okay.
it does go through that process.
All right, thank you.
The other materials that I've handed out, it's more questions that you can use. These are all pulled from various different sites, from the Compass site. Some are created in the likeness of this, and we provide some suggestions for how you want to implement it. Maybe you want to create a Jeopardy game. Maybe you want to cut out each question and give one to a student and have students present them on the board. Maybe you have your own style. Does anybody else have something that, again, they might think would be valuable for that test prep? I know we kind of keep going back. How do you, strategies for kind of preparing students for this type of exam? Yeah, Trina.
Sometimes for certain type of multiple choice questions, I might ask the students, well, how come the other 4 choices are there to begin with? So if they can identify how the test was trying to trick them, they could
Right.
actually look out for that.
So thinking like the test preparer would, why is this question, why is this wrong answer here?
Exactly.
Certainly help.
Using like a teaching tool.
Right.
And sometimes they just give the similar question, like divide polynomial by polynomials. Most times that question ends by +1 or -1.
Right.
Those senior exams, they're similar to each other.
There are definitely questions that are more popular than
Yeah.
others, right?
And like the square root 1, how you were saying earlier, most times the answer is between, they're very close to each other, they end like square of 6, and the other one will be square of 6. So you have to eliminate the other 2, and you're dealing with the other 2. So.
Right. Again, once you see, we're
you
able
have
to
to
see
look
them
at
as teachers more because you can see so many of them. You can see that there's definitely a pattern to the style of questions, and some of these questions are repetitive. There's only a finite number of questions that are there. It's not like they're pulling from all sorts of areas.
So so how many of you play certain kinds of math games once in a while during the semester, right? Jeopardy might be one of them, right? So what do? Does it become pairs? Does it become teams of groups of 4 or 5? Is everybody working at the board? And, are there, you might have different variations.
I was gonna say, we
Yeah.
just have to like each team all about past certain groups of 4 anyway. Like always have them join so they get whiteboards.
And what do? They hold them up?
At the same time, say 1, 2, 3, hold up, and then.
Okay, so maybe multiple groups can get points,
Yeah.
right? So that's a nice way to, how do we address, so kids that are getting it wrong, what's the follow-up? Or maybe this isn't the moment for it, or maybe Jeopardy follows having just reviewed, right? But that's something for us to just kind of keep in mind, right? For the kid who's struggling with this stuff, how are we, how do we use the game? Is it that one of those groups that got it right has to explain why it's what it is, right? Do we, that could be something. right? Maybe they get an extra set of points for doing that explanation, right? Yeah.
You know, when I play the game with my students, there are 4 groups. So we go clockwise to get your questions. But then if the group has it wrong, then we go backward. And the person, the group after that will steal it.
Interesting.
They
Nice
have everybody to
twist.
get the point. If not, then the group after them will have a chance to steal. So everybody has to do the work so that they can steal when the first group doesn't get it.
Nice twist, right? Okay.
So again, these are just some of the materials we're going to continue to share. That's what the PLP is going to be for, the Piazza site. So a lot of you maybe have some great ideas and great resources that we can use to help really prepare our students. So.
All right. Thank you.
Yeah.
Okay, let's keep going. Great. Okay, I don't know, Andrew, you think we should have done this problem before lunch or after lunch? I don't know.
It wouldn't ruin their appetites. Snail?
So some people eat snails?
Escargot.
Escargot.
We had it.
All right. Well, we had some extra lunch in the form of escargot. This problem would be so connected to where we're going, right? Okay, so maybe grab one of those blank sheets of paper that's in front of you. It's always helpful for us to kind of make our work visible, even though you as math teachers probably don't always need to. Okay? So we got this little snail, and have you ever watched a snail move? It's a slow process. The crawling snail, he's got this pole, he's crawling up a pole that's 5 feet in length. And his pace, he can go up 4 feet each day. But then when he goes to sleep at night, he slides back down 3 feet. Poor guy, huh? Okay, so don't call out answers. Just kind of think about it for a second. How long would the snail take to reach the top? Okay? Don't call out your answer. Just kind of think about it for a few seconds. Okay, when you're ready, turn to your partner and share your answer with the partner when you're ready.
Last question.
I'm going to take it quietly so it doesn't give anything away, okay? Where'd your partner go? To God?
He went to the body.
Okay.
You're talking about
Let's just say 7 a.m. every day. 7 p.m.
So after the thank you.
Along with the 5 feet. The bed fall.
Now he can't climb up 4.
5 feet.
Yes.
Okay, so sharing your group, did you kind of come up with... Okay, so here's the next question, okay? What if the pole's 7 feet? What if it was a pole that was 7 feet in length? Then how long would the snail take to reach the top? Okay, go ahead and work on it on your own for a minute. On your own for a minute. Before you share. On your own for a minute before you share.
That makes it up 1.
On your own for a minute. Okay, there's another question up there. These poles keep getting longer. So take a look. The next pole he's going to work on 28 feet.
Oh my God.
What?
Okay.
They got to get it
That's
Can I ask another question?
Now, you could ask for this the rest of the group. It doesn't have to be gender separated every minute of the question.
My question is that I know what it takes sometimes. That doesn't mean that we have to come into account and just get them out of my job.
Right.
Okay, all right, so that answers my question. Which is what I was saying to you.
Put some of the slime on top.
Because you said it's 5 days. So she looks at it and it goes down. But the question says to reach the top. So it's important to
Because
be
I'm non-five,
It's a number of days minus.
not even on day 2, on day 2, it's 5. Think about it this way. Day 1, 6, it goes up 4, and then it goes down 1. So now it goes down 3, so it's at 1. On day 2, where does it go? Okay. You're thinking about it and it goes down also. The question is when it goes down. Yeah, but that's not what the question is. Yeah, that's right.
It's not 2 days. It's a day and a half.
Yeah. Oh, you got another poll? You have another poll? Is the snail prepping for the Olympics? For snails?
Can take a poll. Will be 3 days and a half.
I don't think we So the poll went up to 100?
And then we did 4.
100, what do you think? Poll's 100.
So it will be 3 and a half.
I'm just assuming.
So what is 28? Well, we have to look for something.
What's the next question gonna be? Can you predict it? Can you predict the next question? Well, close. I used M, but you could use M. You were just one letter away. Okay? One letter away.
We have to, you know, Trina, I look at it, between 5 and 7 is 2 feet. Change. This one, 1.5, 2.5, it's also 2 feet. You see that? You change 2 feet. So if you change from 7 to 28, that's 14. Would it be 17 and a half?
Because there have to be 9 feet.
You want to go to it? You want to go to it? Or you want to go to it?
28.
Oh, yeah. What do you think?
This is for 28 days.
From 7 to 28 is 14. 21, I'm sorry.
Okay, let's check.
Yeah.
21.
Okay, so can I interrupt you for a minute? So is there a trick in this, when you start out with this problem? Why might I have gotten this problem wrong first time around? Why might we say, is there a catch? What do you think? What do you think?
At first, when I look at it, not just me, we thought of it differently. And then I read the question again, and the question said to reach the top. So the point is to get there. What happened later on doesn't matter. It's that you get there first. So we thought it was going to be 2.5 days, but it was 1.5 days to get there.
Okay, so you thought it might have been 2.5 days, other people might have had different answers, what did you have?
At first, the given 5 feet is tricky.
Uh-huh.
And when we solve problem based on the 5, it's gonna be confusing. I just ignore 5.
Okay.
I said that they move only 1 inch a day. So starting point is 4. I formulated, so if we make a table, 0 gonna be day first, and then let's say x plus 4 equals 28. I solve this for x. If I find x equals
Wait,
24,
you're going a little fast right now for me, okay? So, and actually you've moved on beyond, because my first question is what might be the error that kids are, so I'm gonna actually come right back to this, okay? Allison, what else? What else might an error be that we would anticipate?
Pretty much, yeah.
What he was saying,
then,
right?
And then like you're saying, is that 1.5 day or is that 2 days? Or, you know, like that kind of.
Okay, Liz?
What I did initially was I, 3 feet minus 4 feet minus 3 feet, that's 1/3 day, so it's gonna take 5 days.
Yeah.
And then Ken with a twinkle in his eyes, like, the pole's only 5 feet long. Once I reach 5 feet, you can't climb up. I'm like, aha, right.
So some kids might jump right into finding that rate per day. That might be a stronger kid that might do that, right? Okay? How many of you drew a picture? So what got you to draw the picture? Was it after maybe making a little off? Yeah. It becomes a...
I don't want to see what was happening.
Just want to see what's happening, right? So that's, that's interesting for us to see in ourselves, right? And, and it's important and it's useful. It's like, okay, we might have first had this little guess thinking one a day, but then it's like, okay, you know what? I'm just going to work this out. These are doable numbers. I'm not going to sit there and feel like it has to magically appear in an algebraic expression. I'm just going to draw out a 5-foot pole and start a little snail moving around on it, right? Okay? Their kids struggle sometimes with whether the 0 is 1, 2. Do you know what I'm kind of referring to right now? But that's a valid and important idea for us to let them struggle, let them see that mistake. It happens all the time. That they want to start with 0 as 1, 2, 3, right? In terms of distance traveled. So an important idea there. Okay, now share a little bit with where you were starting again.
Okay.
Slowly.
First of all, I ignore 5 feet.
You ignore the 5. I don't care how long this is. We know it's a math teacher. She's going to give us more problems.
And then I realized that our slope is 1. Every day is earning 1.
Uh-huh.
So the starting point is the first day he gets 4.
So pause. Pause for a minute, okay? Digest what he's saying, right? Do we kind of see what he's talking about? There's a sophistication in that, right? That's the starting point after a day's travel, right? So
That's not good. After a day, it's not 4. After a day, it's 1.
It's 1, right.
But I said after a day's travel. I didn't say he's in sleep too. But yeah.
So the sleep is not part of the day.
It's a little tricky, right? Am I talking about the 24-hour day or does day mean daylight day? I don't know. Okay? But do we hear what he's kind of saying? That's another approach.
Agree.
To kind of think about what's the maximum you hit after 1 day's travel.
Okay, that's better. I like that better.
Okay? So, but again, how many of you totally understood what he said the first time around? A few. Okay? So it's interesting when we're asking kids to listen to each other, or when we're asking our colleagues at a table like this to explain solutions. How often is the pace, a person's naturally speaking pace is not the pace that we process mathematics at, right? So getting kids to kind of capture that both when they're listening to somebody else or when they're reading a problem, right? The processing time is different. How do we get them to get ownership on that? Okay. Okay, we're gonna do one more snail problem. Here we go. Okay, so take a second. It's a worm. It's not a snail. Okay.
Do you have the answer for the other parts?
I'm kind of.
You don't want to talk about it?
We could.
All right.
But I have a feeling that. Like for your first answer for the 5-foot pole, what's your answer for the 5-foot pole?
Right here.
1.5 days. So it took more than 1 day. So, yeah, 1.5. Because it's at the end of, it's probably 36 hours.
Okay.
Ready?
Yeah.
So many people disagree. Maybe some people are saying 2. What are you saying for the 7? What are you saying for the 7-foot pole? 2?
For the 7, the answer for the 5-foot.
5 foot. So some are saying 2 and some are saying 1.5.
I understand.
Right, exactly. Now kids could have a healthy argument about that, right?
So for 7, someone would say 3.5.
Are we saying it?
They, right? And it's interesting to think about what that means and how you
Well,
interpret
if it
that.
doesn't come with the argument, I don't see what argument can be used for 2. Because if you wait for the full day to be completed, then it's not on there.
Changes the way that I'm thinking of it is on day 2.
Yep.
They reach 5.
How many days
I'm
did
not
it
thinking
take?
about the work, I'm just thinking about on the 7th day. That's when they reach 5.
Who says, yeah.
I was just thinking about depends how you interpret it.
What is a worm?
Well, that's not half a day. That's 6 p.m.
Ah!
Right, so at 6 p.m. So that would be like 1.
So what if we start the day at 12 a.m.? Does that change your problem right now?
What would make it change is what time we start.
Well, 12 a.m. When does the day start? We kind of say it starts right at midnight. Would it change your problem?
No.
It's not gonna. I think it would be 1.
Maybe hibernate?
Maybe 1
You're gonna go that far.
So,
during the
this is
winter
good
time,
conversation. Get started, right?
That's a quarter of.
It's similar.
The thing is, like if I had to say he goes up 10 and then goes down half.
Yep.
I'm doing a different.
Okay. Yeah, that works. That works.
I thought half maybe that it would be interesting, like,
Yeah.
it's not gonna work out.
No, but that works, right? So you kind of create.
Ultimate struggle is making sure the question is clear.
Day 1, he's up 6. He's down to 4. He's up 10. He's down.
I get it.
Hold? No. Huh? I think I'm gonna try to use this. Okay. Okay. So we have the snail, and we had a worm, right? Okay. Let me ask. I'm gonna ask you to go back to the snail for a minute because there was a conversation here that. What is the answer for a snail traveling up a 7-foot pole? Right? If it's a 7-foot pole, how many days does it take? What do you think? 4? Anybody have a different answer? Huh?
With those conditions.
Some people said 3.5. Some said 3.5. And what else? What? On the fourth day, 3.5. And then if we had done an error, we might have said 7 days. Is that right? Is that what we might have said if we were thinking instead about, and we'll kind of just say, well, we eventually figured out that that was not right. How did you figure out that that was wrong? How did you figure out that 1 foot a day was wrong?
Where just to get to the 5 foot top of the pole, you have to climb above it, which doesn't exist. So that kind of.
Okay, so that was just kind of thinking about that, right? And it might have been just that you shared with somebody at your table who had done it a little differently. Somebody who did it with that drawing, right? Okay, how do you address this conversation? Is the answer 4 or is the answer 4.5? Or is it something else? Is it something else? What are people getting at when they say, yeah? What do you think?
You have to know when does day end and night begin.
When does day end and night begin?
I mean, 3.5 days is still the same thing as 4, really, in this case.
In this case, is that for sure, or is it a little bit of an interpretive?
3.5 is not 3 days.
But the night
Anything
could
more
go
than
in,
3 days has to be 4 days.
the night can go into the next day too.
Right? Is 3.5 days have an equivalent fraction on the hours spectrum?
Yes.
So, there's some conversation that you might pull with students on this, right? Okay. Okay, can I hear somebody's example with the worm? Let's hear somebody's. You had a worm. What did your worm do in the daytime? Who wants to share a speedy or slow worm with us?
I mean, I created one, but then I realized it was not such a good one because it goes over, but I don't know what you do with that. But I just started with a hole that's 7 feet, and he goes up 4 and down 2.
Okay, you had a hole that was 7 feet, and this worm does what? He goes.
It's a pole, but hole.
Oh, pole! Okay, that's. Could have gone a whole new direction, negative numbers, but okay, let's keep. I'm sorry. Then what did you say?
So I said he went up 4 and down 2.
Up 4 in the day, and he goes down 2 at night, right? Okay. And then you can kind of create some questions. This could be pushing kids into letting kids create the question that is an X foot pole, right? Okay. Any other bizarre numbers that people created for their worm pace? Yeah.
I have this different perspective. I put in money. Let's say to see better. A worm is saving money.
Oh.
First, he put $10 on his piggy bank. The same day, he spent $5.
Wow. Okay.
In the evening.
Yep.
So he wanna save $20. How long is it?
Oh, nice, right? The mathematics is technically the same, but there is a nice, very different shift in that, right? Very nice. Okay. Worm at the bank. Yeah. Okay. Cool. Any others? Any other worm with some different? Yeah.
I made mine more general, so I didn't use any destination. I said a worm can crawl up a plant 6 feet in one day and slide back 2 feet at night. How long does it take to crawl to the top of a plant that's 12 feet tall, 24 feet tall, X feet tall?
Great. Okay, so we can kind of.
So you didn't remove that other number out.
Okay. Okay, so we're kind of seeing some nice differences. Andrew, can you just kind of shift? Okay, so I'd like you to just take a few minutes at your table to kind of, once again, what's the point? What's the value? What's the product of engaging your students in a problem like this for 15 or 20 minutes, right? This is, again, what we could label as, we happen to be labeling it as non-routine. If you've done enough snails, then the worm's not quite non-routine anymore, right? We know that's true. Okay, but the catch with that snail problem is that little thing about Many might have a tendency to ignore things other than one a day, right? So take a few minutes to brainstorm what is the mathematics in this problem, okay? Think through different stages of your working on the problem. Okay, what were skills, concepts, methods, procedures used? Okay, what's the prior knowledge for this problem? Okay, is this a problem that everybody in your class is going to have access to? Is that different from some other problems where you have a bunch of kids struggling? Okay, what was important outside of the content knowledge for students to succeed in this problem? So just take a few minutes, jot down some ideas, and then share with your table. Okay, what are you kind of coming up with for that?